Okay, am I audible? Someone please reply at the either write in the chat. Okay, and you can also see the slides and it is moving as well. Okay, we will wait for like 5-6 minutes and let the others join in, and then we will start. Okay, so looks like we have enough participants. Let us start. So again, I'm asking, like, am I audible and are the slides visible or not? Someone can just reply in the chat.
Yes, sir, you're audible.
Okay. So yeah, so we are into the week 2 of Natural Language Processing NPTEL course, and in this session, we will have an interaction where we'll discuss some problems and their solutions, and also try to um, like try to understand your problems regarding the same like week. This course instructor is Professor Pavan Goel, who is from Indian Institute of Technology, Kharagpur, and the code is NOC 2020 CS98. I am Punyajoy Saha, a PhD student in IIT Kharagpur. We will be conducting this interaction session as a part of NPTEL teaching assistantship. So let us start with the first question. So the question is, assume that we modify the cost incurred for operation in calculating Levenshtein distance, such that both the insertion and deletion operation incur a cost of 1 each, while substitution incurs a cost of 2. So now they are asking us to calculate the distance between the strings insertion and deletion. So first thing first, uh, what is Levenshtein distance? Can anyone answer? Maybe in short, 1 or 2 lines you can answer. What is Levenshtein distance? Yeah, in more like specific things. Difference between two strings is okay, but how the difference calculated? Difference is fine, but it is not the complete definition. Yes, number of operations needed to convert one string to another, close. Minimum characters and we need to change to convert from one string to another. Yes, this is also close. Minimum characters we need to change, but anyone else? Okay, let us move forward. So, yeah, so the Levinson distance between two words is the minimum number of single character edits or change that are insertion, deletion, or substitutions. So this is important. The operation we can perform are these three only, and required to change one word into the other. So you are like both of you are pretty close in the answer, but you should be more specific. Okay, now definitions is okay, but how do we do that? So this is the formula for calculating the Lewis-Chan distance. So here the basic idea is to try to how do you calculate the Lewis-Chan distance between insertion and deletion? So one way could be to just see, okay, how many changes are required. So you may randomly see the word, okay, these are the changes, and then you decide, okay, these are the number of changes required. But how do you know it is the minimum? So for that, we will use this algorithm. So this algorithm tries to find the minimum change required. So how this algorithm works is you start with so so di comma 0 equal to I. So here it means that that is better to show with an example. So di comma 0, so this is the ith row and this is the jth column, like the j column. Now if we see for each, so let's say, so we have to move from insertion to deletion. Okay. Now let us say we have only this hash character. So now the hash character is here also. So the minimum change required is, so what will the minimum change required here when we have the hash character in both cases? Yeah, none. So, and then if we have d as, then we have hash and d. So then we have to delete 1. Then we have hash de, then we have to delete 2. So this way you have to this way the table is filled. Similarly for the jth, like the first column that we have. So here also, if you want to convert from hash to hash, there is 0. Other cases we have to insert one place. So here insertion and deletion both are 1, having a cost of 1, and others are the substitution is having a cost of 2. Now let us move to, so this part is clear, like the initialization that we have, this part. Uh, so this part is clear for you, right? Why this is happening? Okay. Next we move to the recurrence prediction. Now here what we do, here we then write two for loops, that is to traverse the entire matrix, and in each case we try to find out that minimum of these three values. So this minimum is actually trying to say or trying to find whether we need deletion, substitution, or insertion, and putting the minimum value out of this. So this will automatically select at each step the minimum value, minimum operation that requires minimum cost. And finally, we will have dnm as the distance between these two. So let us try to apply this algorithm in this case. So now we have filled these two tables. Yeah. So let us try to fill this table. So together we can fill. So I will give you, let's say, so you got the idea, right? Let us start filling this part. So what will be this? Can you see the formula, or should I make it a bit bigger? Yeah, can someone fill the next empty box? So what will be the next? So let's say I want to fill this block, this one. Yeah, let's say I want to fill this one. So what will be the calculation? So what is d I comma j? It is minimum of d I minus 1 comma j plus 1. So I minus 1 comma j is which one? So if d I comma I is this one, so this is like 2 comma 2. So d 2 comma 2 is we have to find. So d 1 comma 2 is which one? Yeah. So this will be this column, right? Now we have to add plus 1. So that will become, so the first answer is 1 plus 1. Is it fine? Same for d I comma j minus 1 plus 1. So that will be also I 1 plus 1. So that will be this column. And for the final one, d I minus 1 comma j minus 1. So that will be which column? Which cell? This one, right? And we have to, if I comma j are equal, so are they equal? No. So we have to add 2. So that will be 0 plus 2. So the minimum of these three will be equal to 2. So we can easily fill here 2. Okay. So we have filled one cell. Now let us try to fill this cell. So who can tell what will the value? So next we are trying to fill this cell. So let me color it. Yeah. Yeah. Please write what will be the value for this cell. Can you tell me which one will be the what will be the value for this cell based on this algorithm for d uh, 2 comma 3? Yes, Shubhrata.
Sir, can you show the calculation again? Actually, I have missed this one.
Okay. So what we have to do? So let us say we are calculating for. So let us do this for this cell as well. Let us do this for this. So now we have to use this formula. So di comma j is minimum of these three. So the first is di minus 1 comma j. So tell me what will be the column, what will be the cell, value of the cell, di minus 1 comma j.
1 comma 3.
Yeah. So that is 1 comma 3 is this one, right? Sorry. Yeah, 1 comma 3 is this. No, 1. So this is 3. Yeah, so I minus 1 will be this one, right? So we are doing this for this cell. So this direction it is the I, this direction is J.
Is it 3?
Yeah. So basically you have to take this cell, the 2. So it will be 2 plus 1.
Yes, sir.
And similarly, if you do for this cell, it will be again 2 plus 1. And finally for this cell. So now here so these two are okay. So d I minus 1 comma j and I comma j minus 1. So either way it is fine. So you have to fix a notation. Either you take j this way or j I this way. So that is your choice. But the overall thing will be similar. And finally you have to take d I minus 1 comma and j minus 1. So then you have to check whether xi and yj are same or not. So xi is n, xi is let's say d and yj is n. So they are not same. So now you have to, so this is 2, this is 2, and so this is not same. So here we have 1 and here we have 2 because it is not same. If it is same, then we have to take 0. So here the minimum value becomes 3. Okay. Let us do for so this case also will be pretty similar. So this will be 3 as well. Let us do for this case. Yeah, can anyone tell what will be the answer for this?
So is it 4?
Yes. So now you know how to do it. So this way you have to fill this entire table, and finally the value that you will get here will be the minimum distance. So when we fill the whole table, so if I want you to you can try to fill this whole table uh, in your free time, and then see if you can match the results or not. So the final table will be this. So this value that you are getting here is the uh, final edit distance, and that is also the answer of this question. So for each of this question, you have to create such a matrix and then start filling the table. Only thing you have to notice is what is the cost of deletion, insertion, and substitution. And based on that, your scores will change. So the plus 1 here is the cost of deletion or insertion, and then the cost of substitution. So 2 is the cost of substitution. So you can also change the cost differently and then see what is happening. Okay, any doubts here? Okay, moving on. So this question is also pretty in the same lines, but here, yeah, so this is done. So next is how many insertion, deletion, and substitutions were required corresponding to the optimal alignment obtained between the strings in question 1. So here it is written that after solving the question 1, we found the minimum distance, right? So we found that 7 is the minimum distance. Now the question is, what is the changes that were required? So we have found that okay, 7 is the edit distance, but what changes are done to make that 7 do that 7th edit distance? that is required here. So how to solve this? So can we somehow use the edit distance like the table created earlier? So do you have any like thoughts about that? So I have already highlighted some things. So maybe you can guess from that. So how should we use this table to find uh, the optimal alignment? Can you guess it? I have already like highlighted some parts, so you can like there is already a hint in this picture. No one?
So,
Yes.
so when we move diagonally, like from
Hmm.
7 to 7, so that's where we don't change anything.
Hmm. Yeah. So how do you know you have to move from 7 to the diagonal 7? So what is the like the intuition? Why do you want to move to 7?
So, because you highlighted it.
No, no. Just think about it. Yeah, highlighted is this. I have shown the answer, but why
Yes,
should we move there? It is very simple. If I tell you, you will say, "Oh, this is the." Just check. So for each cell, you have to move somewhere. Now, how do you decide where to move? Just think about it. It is very simple. Check for each example what we are doing. Like from each
So
cell,
choose the minimum distance.
yes, exactly. So that is the answer. So when we have the final edit table, so usually these questions are like this. So you have to first find the minimum edit distance and then find the optimal alignment. So to find the optimal alignment, you have to start from the like the last cell, that is D I comma J or N comma M, and then move towards the minimum value from each cell. So from here, from this 7, we are moving towards yeah, we are moving towards this part. So this is the minimum value. This is the minimum value. This is the minimum value. So here, and you see there is no change in the value. So we know that there is no substitution required. Then till here we are fine. After that, when you move here, we are substituting. So we are substituting R with E. Then from here we are moving here. So in here 5, we have to see this 3. So the 4 is the minimum value. So we are moving this way. So we are deleting. And here also we are not changing anything. It is same. Here we are substituting, and finally we are deleting 2 times to reach here. So if you see the results, so this will be the final result. No substitution till here, substitution here, deletion here, then no change, again substitution, again to deletion. And here is the answer. So backtrace the edit distance table as shown in worked out solution for question 1 to find the optimal like the insertion, deletion, and substitution along the path. Okay, I hope this is clear. Any questions or doubts you may ask?
So, doubt.
Yes.
So, how do we know when deletion is occurring through that table?
Yeah, so for this table, so you have to check. So our final, let's say our final row thing is deletion. Final word is deletion. We have to move from insertion to deletion. So, so in this table, so we have N O. So when we are moving towards, yeah, so we are deleting here. So when we are moving towards horizontally, then it is deletion.
Okay, sir.
Okay, moving ahead. So yeah, so this was like two questions combined, something like that. So the next question is about, let's say a corpus is of 3 sentences. Now, what is the total count of unique bigrams for which the likelihood will be estimated? And we are not performing any pre-processing, so the corpus is as given, like as it is. So before even going to the question, so what are unique n-grams? So here it is bigrams, but let us generalize a bit. So what are the unique n-grams? So how do you know uh, the n-grams, or let's say what are unique unigrams? Can anyone tell what are the unique unigrams, or what are unigrams in general? What are bigrams in general? What is an n-gram? Anyone?
So in general, when we talk about bigrams, we take the present word and the preceding word.
Okay, the consecutive words, yes. And how do you
Yes.
like generalize a bit? So let's say then what will be the n-grams, and then what are unique n-grams? So you have defined it for bigrams, okay, but what are n-grams first, and then what are unique n-grams?
So n-grams will be the number of the consecutive words that we'll take, the n number of consecutive
Number of
words.
consecutive words. And unique, that does not repeat in the entire thing. So you have to first find the n-grams here, and then apply a unique function to get the unique n-gram. So you have to see, like, create a set out of it. So can you suggest some of the bigrams from here? Just write it in the chat. So there is one hidden thing that is not given here, but we have to use that. So anyone who can guess it, but in any sense, like, let us first write some bigrams. So just mention in the chat what are the bigrams. So write some few examples. Here we are not looking for unique in bigrams, but we are trying to say what are the bigrams. So just write like as you find them. Anyone? Yeah, can you write the bigrams? At least write one of them. Yes, anyone who can write? Yeah, when Alice. Okay. Anyone else? Yeah, the more you, I think the more you interact, I think more you will know what are the problems that you are facing. So it is better that you interact with. Yeah, so yeah, so Abraham, yeah, these sessions are getting recorded and it will be uploaded on YouTube. So just try to see what are the diagrams. So it is very easy. Anyone else? Okay, so I think you are correct, Pranav. These are the total diagrams. Now the thing that I was saying, like the hidden factor. So the hidden factor was this S or the starting token. Starting and ending token are the extra thing. So whenever you are whenever you see such sentences, you have to always add the starting S token and the ending S token and then calculate the bigrams. So here if I can modify, so this will be the final sentence that you get, and then you can calculate the bigrams. So always remember this, that you have to add the starting and ending token to get the correct answer. Okay, so now how many are there? These are the total unique bigrams. So there are in total 17. So that would be the answer. Any doubts over here?
So,
Yes.
so what if there is a comma?
So if there is a comma and you are said that it is not pre-processed, so you can take the comma. So if there is a comma like this, then it is considered a part of the word itself. Can you see it? And if there is a comma is like this, it can be considered a separate word.
Okay, sir.
But if there is pre-processing, so in pre-processing they may say that okay, you have to remove the punctuations. So in that case, you have to remove the punctuation first and then do the processing. So
Okay.
similarly for full stop as well. Okay, so the next question is a trigram. So we have already cleared what is n-gram. So trigram is 3 consecutive words in a corpus. So a trigram language model is a dash order Markov model. So so a language model, what is a language model? So what is a language model? Can someone tell? Okay, so simply a language model is that provides the probability distribution over a sequence of lengths. So usually what happens is you have got let's say n tokens, and then you have to predict the next token based on probability. So now the next question is, what is the k order Markov model? So what is a Markov model first? Anyone guess? So a k-order Markov model is so looking a k-order Markov model looks into the previous k tokens to select the next one. So that is similar to it is k-order Markov models look at the current k tokens to predict the next token. And a k-gram language models looks at k minus 1th terms to predict the next one. So what will be a k-gram language model is the same order as a k minus 1th order Markov model. So here a trigram language model. The trigram language model means it looks at trigram of 3 words. So it is a trigram language model. So it looks at 2 words, 2 previous words, and the 2 previous words looking Markov model is known as second order Markov model, which is the answer to this statement. So by definition, an n-gram language model is a n minus 1 order Markov model. Okay, so this is a fun experiment. So let me just so this can be done by everyone. So you are given in these like 4 words: tea, coffee, wine, and juice. And now you have to search in Google Books. So let me also open it. So we have to search in Google Books what is the increasing order of their n-grams frequency. So if I open the Google Book thing, so have anyone tried this? Hello?
No, sir.
Okay, just open it. So here so you can see my tab. So here we can see, so you can do this for other words also. So this can be a good experiment. So just give tea, coffee, wine, and juice. So let me do for tea and coffee. Tea, comma, coffee. Okay. So now we get a distribution. So coffee is greater than tea overall. So this provides the overall percentage. So coffee is greater than the frequency of coffee is greater than tea. Now you can do it for all the 4 and let me know what is the ascending order. So here the ascending order is tea, comma, coffee. So what will be the ascending order for this case? So put the ascending order as well as the values, so the approximate values as well. Yeah, what will be the ascending order? Just write it down. Anyone? So you have to write a comma and then the next word. That should be enough. No, that is coffee, juice, tea, wine. No, are you seeing it in the graph? In the final, the graph that is generated?
So in the graph, coffee is still on the top,
Yes.
followed by wine, tea, juice.
Yeah, so what will be the ascending order?
Okay, in that sense.
Yes, yes.
So
This is what we
juice,
have.
tea, wine, coffee.
Yeah, juice, tea, wine, coffee. Yeah. So you can try for other words. So can you suggest some words that we can compare? Just random words you can think. This is from the Google, like this is the uh, like the frequency distribution from the books that are stored in Google. So from that. So let suggest some random words and let us check what is the frequency distribution.
Dog, cat, fish.
Yeah, try it and show like so you can try it here. Yeah. Share this tab. So what is your prediction?
Maybe dog should be at the highest.
Okay, let us see. Yeah. Dog at the highest, then fish and then cat. Interesting. Anyone else with any other suggestions? Otherwise we will go ahead. Yeah, so this link is available every time, so you can just try it, like try to see whether your predictions are correct or not. Okay, let us move ahead. Sorry. Yeah. So next there are so this 6 to 9 questions are there, like, and this is the corpus that we'll be using. So I will return back to the corpus if necessary. Here you see that we have already added the starting and ending token. So these are already present. So you do not need to add it. And this has 5 sentences. And let us move to the first question. So consider trigram language model that has so w minus 1 be a non-existent empty word. So minus 1 we do not need to care about. That is empty. W0 is equal to a starting token and wn plus 1 is equal to the ending token. So, and they have given a formula to calculate the probability estimate of a sentence. So what will be a probability estimate of a sentence? So P word 1 given word 0, P word 2 given word 1, 0 comma 1, P word 3 given P W 1 comma 2. So if you notice, for each word, if there is a word existing, like 2 words are existing before that, we are taking them and trying to predict the third word. So this is from the conditional probability. So given W0, 1 is there, what is the probability of the W2 from this corpus? So, so we have this sentence, that is the first sentence here. Sorry, the second sentence here, I guess. No, okay, this is a separate sentence altogether, and we have to find the probability of this sentence. So what we will do, we will separate the formula. So the formula will be Can anyone guess what is the formula? So we have to find the probability of the given sentence. Yes. So it will be P. So W0 and W1 is this. So $S Michael given $S. You have to find this first. Then we have to find and given $S and Michael. What will be the next term? Yeah, please tell what will be the next term.
Zach and
Jack and what will it do? Like, what are we trying to from where are you trying to predict it? Michael and yes. Similarly, you have to complete this whole thing. Since this is a trigram, we are only focusing on 2 prior words. So if it was 5 gram, 1 prior word. If it was 4 gram or like that, then you have to use 4 words prior to that. Sorry, 3 words prior to that. So you can calculate this this probability. So how will this probability be reached? So you have to again go back here, select all the trigrams and see. So for example, let us take this one, P and S comma Michael. So what we have to select? We have to select all instances of starting token and Michael. So how many instances are there? Starting token and Michael, one example. Then starting token and Michael, none other, right? Anything else like starting token and Michael?
no, sir.
No. So we have one. So here, let me write it. So we have. So I'm showing it for one, but others will be similar. So and so there are only one token for this. S comma Michael. So this will be frequency. And we have only one token for this. Michael and then and equal to 1. So the probability will be 1 by 1. That is like the shear event. If there was another sentence where this was the case, now what will be the probability? Now there are 2 Michaels.
It will be 2 by 5 here.
Yeah, 2 denominator and numerator. Numerator will be
Numerator 2, denominator 5.
no denominator is how many instances of S comma Michael. Starting token of Michael are there, and numerator is how many tokens of these 3 are there. So P of these 3 S Michael and by P of S and Michael, or frequency of S and Michael. So here also it will be 2, right? So we have like and is only 2 times here. So this is the unique token again. So then also it is a shear event. So it will be just 2. This will be also 2. And again the probability is probability equal to 1. Probability of this thing and Michael and given starting token and Michael is again 1. So similarly you can calculate the probabilities for other words as well. and it has been shown here. So P Michael is 1 comma 5, and comma Michael has find out 1 comma 1. So this is again you can find out so how many $S is there, like the token starting token S is there, and how many times it is Michael. So it was different here. There it was Bob comma Michael or something like that. So there are 5 sentences, only one is having Michael, so that is why it is 1 by 5. So similarly, you can find out the other cases. And finally, we have to multiply all of them. So according to this formula that is here, and you get this one 1 by 60. You can verify the formula later. So at your free time, this will be all like uploaded. But you understood the procedure, right? How you want to do it. Oh, so this will be our last question of this today. So given the same language model, what is the perplexity of the sentences? So the sentences was this one. Now they want us to find the perplexity. So we already found the P or the probability of the sentence. Now we have to find the perplexity. So how do we calculate perplexity? And what is perplexity? Can anyone tell? So what is perplexity? No one? So perplexity is the inverse probability of the test data normalized by the number of words. So it is simply P W1 comma W2 comma Wn to the power minus 1 by n. And that is again divided into like the number of n graphs that we are looking at. So here we have already got this term, right? P of this one. So that is 1 by 60. And what is n here? What is n in this sentence? This one.
3, sir.
No, what is n here? N in this sentence. N is not for n graph. N here is, so this is a different notation, sorry about that. So n is the number of words in the sentence. So here number of words are 1, 2, 3, 4, 5, 6, 7, 8, 9. So now tell me what will be the final formula?
Nine by 60.
No, think about it. So P, this part we already have. So we have, let me again make our text box.
So 1 by 60.
Yeah, P we already have 1 by 60. We have N which is 9. So now what will be the formula for perplexity? 1 by 60 to the power minus 9, right? Sorry, minus 1 by 9. So if you put it in a calculator, you will get, I think, yeah, we will get the answer C. So you will get 1.57, this one. Yeah, so there are a few more questions, but they are pretty similar to what we have solved now. So just go through them and let me know if you have any doubt about them. So if you have understood till here, then you will be able to solve the rest of the question. Here also you have to do the same, like calculate this sentence probability. So it's the same. Then you have to calculate the sentence with the highest probability estimate.
Mm.
And finally, there is one question that is for homework, so that you can try on your own. So this is again based on the formulas that are already present in the lecture. And finally, you will get the vocabulary size. So just check the formula for Laplace smoothing and all this, so you will know how to do it. And let me know in the next session if you have any problem. Okay, so as usual, we have our slides and the YouTube like channel here. So usually it is like 1 or 2 days delay. After that we'll find the video and the slides. And I have already added this links in the discussion forum, so you can check them out as well. If you want to check the past week's slides and video, you can check it.
Sir,
Yes.
sir, what is the name of the channel? This channel.
You can just wait a second. I have given some brand name, teaching experience or something like that. This is the link for the channel. This is the link
Okay,
for
okay, I
the
will check.
slide.